going to try and do this as clearly and as simply as possible. So let's try draw a circle first. It's pretty much a circle. What color will I use? Green. So at some point after it's left the position where it's rolling from. This is the position of P and Q. Okay. They're at opposite ends of the circle. Let's say the center of the circle's here. And we want to say this is A and this is A. Now the origin at this point is over here somewhere, right? That's where P was before the circle started rolling. And the question is, what are the new coordinates of P and Q? That's what we're going to need to work out in order to do this step question. Yeah. That's just simple trigonometry because at this point, it's moved an angle of theta. Now, the center of the circle, after a time of, t has passed, so we're given that when time t has passed, the hoop's rotated for an angle of theta. Now, if you think about it, what has happened at the bottom here is that how much circumference was traced out? Well, this distance here is just going to be a theta. Okay, so the new coordinates of the center of the hoop are going to be a theta and a, right? So it stays a constant height. Okay, so all that is good. Now, relative to the position of the center of the circle, we know P and we know Q quite easily here, right? Because the coordinates of P are just going to be, you go down by a, what is it, cos or sine? It's gonna be cos, right? Yeah, cos on this side, I think, and sine on this side. Yeah, so that's gonna be a sine theta. So really, the new coordinates of P are just gonna be, at a general point, it's a position vector. Just gonna be a theta minus a sine theta. And this bit's going to be a minus a cos theta. So there we go. We wrote down the positions. Now when now we have to determine the speed of P in terms of a theta and theta dot. So what's the speed of P going to be? Well, I'm just going to differentiate this thing component-wise. So I get a theta dot minus, and using it general, a cos theta dot. Down here, sorry, that should be theta. And down here, I get a sine theta and a theta dot. Okay. To get the speed of this, well, it's just going to be the magnitude of the velocity vector. Okay. So I'm going to end up squaring and summing the components. That's how you take the magnitude of a vector. But in order to do that, I'm going to factor out an a theta dot first. So that's going to be, because I'm squaring a squared, theta dot squared. And then what's left on the inside? Well, I'm going to have a 1 minus cos theta squared plus sine squared theta. Okay, and this will roughly simplify. We can see that expanding this out, you get a cos squared plus a sine squared, and that's going to be 1. And then you're going to have a minus 2 cos theta. So you can simplify that as 2a squared theta dot squared. And that's going to be, what we're going to have left is just 1 minus cos theta. Okay, so that's the speed of P. And then finally, we want to show the kinetic energy of the two particles together is 2m a squared theta dot squared. So in a really similar way, you can work out the speed of Q. Okay, so the total kinetic energy of this system, because the only mass is in the 2-point particles, it's just going to be contained within B and Q. So we just want the speeds of P and Q. That's the only contribution to the kinetic energy because it's the only mass of the system. So in a really similar fashion, we can see that the position vector of Q is actually going to be almost identical to P. I'm just going to replace these minus signs with a plus sign. I can kind of go through the same algebra, but I'm just going to skip that for the sake of a short video. And if this is the speed of P squared, right? The speed of Q squared is going to be well, let's change color because I don't want to confuse the reds. It's going to be 2a squared theta dot squared. Something nice is going to happen here. So it's going to be 1 plus cos theta. Okay, then we know the total kinetic energy of the system is going to be a half m vp squared plus a half m vq squared. And we can see that the cos theta is going to cancel out, and we're just going to get exactly what we want. Right? We're going to get this result up here, that the kinetic energy of the two particles is 2m a squared theta dot squared. Okay, what's the last bit then? This is actually really short. So given the only external forces on the system are gravity and the vertical reaction of the table and the hoop, show that the hoop rolls with constant speed. Well, you hear the word constant, you might think about, I don't know, differentiating something and setting it to 0, whatever. But in a very mechanical context, the word constant usually refers to you attempting to conserve energy somehow. So what we want to say is that energy is conserved. That's true if there's no energy coming in or out of the system. If you look at the only forces acting in the system are gravity and the vertical reaction of the table and the hoop, those forces are actually going to cancel out. Yeah, so there's actually no net work done in the system, so energy indeed is conserved. And what do we know about the energy? Well, we know that the energy, there's GPE plus kinetic energy. It's conserved, right? So that's constant. Now, if you think about the way the hoop is rotating, these two particles are always going to offset each other in terms of their gravitational potential energy, no matter where I take the origin of my potential to be. It's going to be constant, right? So they're just going to be rotating in such a fashion that they're always going to, I mean, you can see this clearly by taking the origin of the potential to be here. Then the potential is always going to be 0 because these are just rotating around it. They'll always be equal distance away from each other, right? The distance 0 away is going to be a cos theta from the 0. So GPE is conserved. Hence, GPE is constant. So if this is constant and this is constant, we know this is constant. So the kinetic energy is constant. But we knew the kinetic energy was 2m a squared theta dot squared. So you can quite easily deduce that theta dot is constant. And if theta dot is constant, therefore our system rolls with constant speed.